Good morning, friends. Welcome back to Brain Sizzlers. Well, in the recent past, it has been observed that quite a lot of questions have been asked in the arena of income, savings, and expenditure. So, we shall try to deal with all of them in this video. Particularly, our topic for this video is percentage change in savings when both income and expenditure are on the rise. We'll start with an example. Actually, we will try to solve this example in a very conventional method, and after having solved it, we will sort a way out to solve it in a more easier way, because trying to solve it in a conventional method will try to be too cumbersome. So after having finished this solving this example, we will find a mathematical relation which will relate percentage change in savings, percentage rise in income, and percentage rise in expenditure, which might be quite fruitful for most of the examples of these types, and for all the problems involving expenditure, savings, etc. So now we will start with this. If a person spends 75% of his income, and if his income rises by 20%, and if his expenditure rises by 15%, what will be the percentage change in savings? Well, that is the question asked. We will try to solve how this one works out. Let us keep the initial income to be I in, and since expenditure is expressed as a percentage of income, and that too 75% of income, so E in, initial expenditure, is being given as I in into 75 by 100. Now the revised income will be 20% more than the original income, so I in plus I in times 20 by 100, so I in into 120 by 100. So the revised expenditure in turn will be, when expressed in terms of initial income, will be I in into 75 by 100 into 115 by 100, because expenditure has been told to increase by 15% from its previous value. Now the revised savings will be the revised income minus revised expenditure. So everything we are going to express in terms of initial income. The variable we call it as I in. So finally, after calculating, we get the value to be I in into 27 by 80. The old savings will be old income minus old expenditure, which amounts to I in into 20 by 80. So when the old savings is given a yardstick of 100, the new savings will be found by the normal direct proportion logic. It will be found to be 135. So straight away the rise in percentage savings will be 35. Now solving in this method is obviously quite cumbersome, so we will find a way out to mark a relation between percentage change in savings, percentage rise in income, and percentage rise in expenditure. So that's exactly what we are going to do. Let again the initial income be I in. Let Y denote the percentage rise in income. Let the expenditure be X percentage of the initial income. Fine. So E in is expressed as I in into X by 100, and initial income is I in, and since Y is the percentage rise of the income, so the revised income will be 100 times I in plus I in into Y whole divided by 100. Fine. Now the new income will be, the new expenditure will be the old expenditure plus the rise in expenditure. So let Z denote the rise in percentage of expenditure. So E new, that is nothing but the new expenditure will be old expenditure plus E in into Z by 100. Finally, the E new will be E in into 100 plus Z by 100, where Z denotes the increase in percentage of expenditure. The initial savings is given by S initial equal to I initial minus E initial. Initial income minus initial expenditure. So savings initial will be I initial into 100 minus X by 100. So savings new will be new income minus new expenditure. So as we know how to correlate everything in terms of initial income, so we have expressed the revised income to be 100 times I in plus I in into y whole divided by 100 minus revised expenditure will be expenditure initial into 100 plus z by 100. So everything when expressed in terms of initial income itself, so the final value will come like this. Now when new savings is expressed as a percentage of old savings, so obviously the old savings will be given a yardstick of 100. The new savings will be found out to be this value given by equation number 4, 100 square minus 100y minus 100x minus xz by 100 minus x, where y represents the increase in percentage of income, x represents the percentage of income which is expenditure, and z represents the percentage rise of expenditure. So case when the savings, the revised savings is greater than the old savings, obviously the one given by equation 4 will be greater than the 100 when suppose the initial saving is given a yardstick of 100. So we have to subtract 100 from the value given in 4. So when we do that, what we will get as the percentage rise in savings will be 100y minus xz by 100 minus x. This is a very important formula for most of the competitive exams like XAT, CAT, etc., wherein both income and expenditure are on the rise and the rise in percentage of savings is being asked. We can directly use this formula where y represents the percentage rise in income and x is nothing but the percentage of initial income expressed as the expenditure, and z is the rise in percentage of expenditure. Fine. Case 2, when the old savings is greater than the new savings, it will be absolutely vice versa. So the revised value of savings given in equation 4 has to be subtracted from 100. So the percentage drop in savings will be the exact reverse of that obtained in the percentage rise in savings, which will be xz minus 100y by 100 minus x. So if we substitute any of these two equations in the example that we considered earlier, it would be we would be able to solve it much easier. Say for example, in the example that we considered, the y was nothing but 20. There was 20% rise in income. So 100 times 20 is 2000 and x was 75 and z was 15. 75 times 15 amounts to 1125. So when we subtract 1125 from 2000, we get 875, and 100 minus 75 in the denominator will give us 25. So 875 by 25 will give us 35. So percentage rise in savings is 35. That is the exact value that we got in the example. So if we recap the example, the final answer that we got in our example was 35. Here it is 35. So the same 35 can be obtained from a single formula. Okay, which we can either apply percentage rise in savings formula or we can apply percentage drop in savings. In either way we can get the answer, because if we are assuming it to be a rise and if we are getting a negative value, it will obviously be the drop. So hope this video will be quite useful. If you find it really fruitful, do subscribe. Thanks a lot for watching. Have a nice day.